All right, hello class. So me and Justin are gonna go over two homework questions that there was confusion with, and I hope we can kind of break them down and make them a bit more understandable. So the first one is in chapter 11, and your problem should look kind of similar. So I just took the first one that showed up. Basically tells you about the exchange rate in Rome and Los Angeles. So first of all, first difficulty students might have is how to interpret this number. So basically this number says that €1 in Los Angeles is worth $1.5592. So I wrote this here down. So always think of this back end, basically the singular value of the currency, and this part as the other currency. So basically, if it was flipped around, it would basically be saying $1 is worth so and so many euros. First question asked is if you would want to make a profit, where would you buy the euros and where would you sell them? So because 1.582 is greater than 1.592, you buy low in LA because in LA it's cheaper, as you can see, and then you sell in Rome. To kind of make that understandable, I drew a little graphic. So imagine you're in LA and you give the bank $1.5592. The bank gives you this one little euro coin back. So now you have €1 and you paid $1.559. Then imagine you can fly instantly to Rome and you give Rome, you give them this €1 and they give you back $1.5802. So what happens, you actually made a profit of $0.021. So that's why you would probably buy where it's low and sell where it's high. I hope this example kind of makes sense a little bit more when you think about it. So the second one is the same problem, just in terms of euros. So now it says investors face the same exchange rate, but now they kind of flip it. So firstly, you want to basically get the dollar to euro exchange rate and then from euro to dollar. So I calculated that here. So we know that one euro is so and so many dollars. So we basically just here divide it by this number, and then we get this euro to dollar, where basically $1 is 0.64135 euro. And then where would investors buy, they ask you, and then you can basically draw the same graphic. But if you just think about it, in Rome you can buy $1 for 0.63283, and that is cheaper than buying $1 for 0.64135. I also, with those kinds of things, like to think in the extreme. So imagine I told you a country basically would give you $100,000 if you give them €1. What would you do? You would probably stop everything you're doing. You would go to your local bank and say, I just need €1. Just give me €1. I don't care how much. You would fly to that country and then give them the euro and take your $100,000 and be very happy. So that's why I always, if you're unsure, think in the extreme scenarios, and it should make sense of why you would want to buy the dollar cheaper. It's also kind of weird thinking of buying currency with other currency, but that's probably the biggest problem. But in essence, it's pretty simple. The last one, what they ask you is, so here I did the same kind of scenario again. Once again, you imagine you're in Rome, you buy here, you give them 0.63 euro and you get the dollar, and then you fly to LA, and for the dollar you get so and so much euros back, and then you once again made a profit. The last question they ask you is what would happen to the per dollar euro exchange rate in Rome? So the dollar per euro exchange rate, we go back to this problem. This is the per dollar euro exchange rate. So if everyone hears about this, basically the exchange rate will fall, and soon you won't be able to make a profit. And that's when the market is in equilibrium. So that's why the answer would be exchange rate will fall and the dollar per euro exchange rate in LA would rise. So yeah, this is mine, and now Justin prepared something for question 6.
You just make me co-host real quick. All right. So I'm going to be going over question 6, and in this one we're going to be talking about covered versus uncovered interest arbitrage. So the problem starts out with, say on June 5th, Rajiv, an American investor, decided to buy 6-month treasury bills. He found that the per annum interest rate on the 6-month treasury bills is 7% in New York and 11% in Frankfurt. Based on the information and assuming that tax costs and other transaction costs are negligible, so we're not taking those into account, it is in Rajiv's best interest to purchase 6-month treasury bills where in New York or in Germany. So basically, the way you can calculate this is we can figure out the extra interest rate using this formula right here, where we have the foreign interest rate minus our domestic interest rate. And then this is technically divided by the number of periods. So since the treasury bill is a 6-month period per annum, then it's going to technically be 2 periods in a year. But anyway, you can just figure that out by basically dividing 12 divided by 6. So that's what's going to get us 2. And so then when we plug the foreign interest rate in, which was 11% in Frankfurt, and the domestic interest rate, which was 7% in New York, since he's an American investor, he sees that he's going to get a 2% more interest rate, or higher interest rate, if he bought the Frankfurt treasury bill. So in that case, he's going to want to go with the treasury bill from Frankfurt because he's going to earn 2% more for the 6 months. However, we do have to take another factor into account, and that might be fluctuations in currency, right? So this follow-up question starts with, on June 5th, the spot rate for the euro was 0.820, and the selling price of the 6-month forward euro is 0.822. At the time, Rajiv chose to ignore this difference in exchange rates. In 6 months, however, the spot rate for the euro fell to 0.18 per euro. When Rajiv converted the investment proceeds back into US dollar, his actual return on investment was what? So basically, what we're trying to do is we're trying to figure out the uncovered interest rate, and this is some sort of uncovered interest rates due to fluctuations in foreign currency. So basically, the way we're going to figure that out is we're going to use the new spot rate for the euro. So we saw that it fell, and it fell to $0.81 per euro. So we're going to plug that in right there. We're going to use the original spot rate. And in essence, this equation is simply just a percentage change equation. So that's going to be 0.820 right there, divided by the original times 100. And then we see a loss of 0.24%. So when you add that 0.24%, and I'm sorry, that should be a negative right there. When you add that 0.24% to the original extra interest rate, you see that in actuality, his actual interest rate would be 1.76%. So that's his actual return on investment when taking the fluctuations of currency into account. Now, in this case, he didn't, I believe he didn't originally take, does not obtain exchange market to protect themselves from fluctuations in foreign currency. So he's not taking that into account. Now, as a result of this transaction, Rajiv realizes that there is greater uncertainty about how many dollars he will receive when the treasury bill matures. So he decides to adjust his investment strategy to eliminate this uncertainty. So he's trying to eliminate the uncertainty of the fluctuations in foreign currency. So this is more of a which of the following. So what should Rajiv's strategy be the next time he considers investing in treasury bills? And the answer is going to be to contract in forward market to sell the foreign currency in the amount of the proceeds for the investment. So since his expected return is greater than his actual return, he's going to use a strategy called covered interest arbitrage. So this is going to eliminate any uncertainty that he has after foreign currency conversion. if he were to invest in a foreign treasury bill, he would contract in the forward market to sell the amount of foreign currency expected as proceeds from the investment with a delivery date to coincide with the maturity of this investment. And this kind of all makes sense here in this last problem. So had he used this covered interest arbitrage on June 5th to take into account the fluctuations in foreign currency, what would his net return on investment be relative to purchasing the US Treasury bills in German 6 months Treasury bills? So it's going to be 2.20%. And in this case, we're going to use the net return, which is a net return equation, which is basically going to be your extra interest plus the covered interest that covers you for the fluctuations in exchange rates. So you're going to use, in this case now, for the covered interest rate, the forward spot rate, which we had above, which was going to be 8.22. So 0.822 dollars. And then you're going to use the original spot rate, which was 0.820, divide it by the original. And then in this case, I'm not converting them to percentage form until the end. And then for the extra interest rate, we use the same equation, add them together, and then you get 0.022, or in percentage form, 2.20%. So by using the covered interest arbitrage, he would have received a net return on investment in 6 month treasury bills of 2.20%, which is greater than the uncovered, which we saw above. So basically what this is trying to show is by using that covered interest, he has a higher return on his investment. So that's all for me. I didn't know if Alex had anything else to say.
No,
But
nothing to add, and I hope this helps you guys a little.
thanks.